we discussed that we cannot separate these two, or the limit of the difference of these two functions into the difference of limits. Simply because the limit of the first function and the limit from the second function, actually, they do not exist. Agreed? Okay. So obviously, we discussed that last time. We factor the denominators. And we cannot even plug in at this point. So we have to wait for a moment. So x approaches 0. And we found the least common denominator to be x times x plus 1. And now we need the adjustments. What would you multiply the numerator of the first fraction and the numerator of the second fraction by?
First one multiplied by x plus 1.
Awesome. I can't speak tonight, so maybe I should just keep my mouth shut. I can't speak. Okay, thank you. I meant to say awesome. Okay, thank you very much. So now the second one. Anything, indeed, or just 1. Perfect. So the numerator becomes x plus 1 minus 1. And of course, we will simplify because 1 minus 1 is 0. And then we continue, do not drop the limit operator. We have x over x times x plus 1. And obviously, I will simplify again by x. And the simplified form will be x approaches 0, and this is 1 over x plus 1. Now, this is a very, very wonderful situation. I said I can't speak tonight. Exactly, and you're done. So there is nothing else. So this was, in my opinion, quite straightforward, but only after you find the least common denominator, you simplify, or you subtract the two fractions, and you come up with this. And once you come up with that simple fraction, then you're done.
Wait, why did you put the 1 over the 1 at the top? Is that all it needed in the denominator?
No, it's not needed, but some students, when they simplify, they put 0.
Oh, no,
Or they put 0 here. Oh, that's not what you meant.
We're doing least common denominator. We're multiplying.
You mean up here?
Yeah.
You don't have to write anything. If it's 1, you don't have to write anything because it's the same denominator. If you don't want to write it, you don't have to.
So you only needed something on the left side?
On the first fraction, because x was multiplied by x plus 1 to get this. But this denominator is the least common denominator itself, so I can't do anything to it. I don't have to multiply the numerator.
Okay.
It's like saying, let's say, 1/2 minus 1/6. The least common denominator is 6. Only this one needs a 3. This one doesn't need anything because it's the same denominator. So then I have 3 minus 1. So that's how I get 2/6 or 1/3. So the same thing here. You don't have to write anything. Some students, they like to write something. Others, they don't. So it's up to you. Okay, perfect. Let's look at an absolute value and then move on. So another limit would be something like 49. Now let me ask you if that's what you wanted, or maybe you want to choose something else. It doesn't matter. So I was looking at 49, but it does, as I said, you can choose any other limit with absolute value. So we looked at 46, and I selected on the list of limits. Which one?
It's closing.
I know. It didn't work. Okay, where was it? Here. Okay.
Anything with absolute value?
Yeah, so all these have absolute value in them. We can't spend too much time on choosing, though.
43.
We want to look at 43. Which one?
42 or 43. Either one's fine with me.
Okay, which one?
I just like the number 42.
42 it is. Done. Okay, so here's 42. In 42, we have limit as x approaches -6 from either side from 2x plus 12 divided by the absolute value of x plus 6. You okay? Good. Perfect. So our starting point must be with the absolute value of x plus 6. And we know we will discover two options. Can anyone give us those two options? See what happens to my markers?
We're just looking at it. I'm not actually fine.
So the x plus 6, x is larger or equal to -6.
I have to write it like this first. It's not a mistake what you said, but I need to show this first.
Okay.
And the second option?
Um,
Negative x plus 6.
I hope you mean this. And
that one's x is less than,
perfect. So therefore, I'm ready to simplify the function now. And I have the numerator, I hope you agree, can be factored how? Yes, and parentheses. Very good, awesome. And now the denominator is the absolute value of x plus 6. So this entire function has two options because the denominator has two options. What is the first option?
Can you cancel out x plus 6?
Of course, so the first option is 2, but only when, so this was x greater or equal to -6, only when is greater than -6, not equal to. How come? Why I cannot include -6 this time?
Because that would make it 0.
In the denominator.
In the denominator.
Perfect, okay. So, of course, this one, you do not ever have to solve the second one. If this one is greater or equal to -6, this one has to be less than -6. Okay, what is the other option?
Negative 6 doesn't exist.
When this gets replaced by that, what do we get? What is left?
-2.
Thank you very much for x less than -6. So now we completely simplify the function. There is no more absolute value in it, so it's completely algebraic now if you want, some super simplified. So now I'm ready to determine this when x approaches -6 from either side. In order to come up with an answer, I have to determine the limit when x approaches -6 from the left, and I also have to determine the limit as x approaches -6 from the right. And then I will conclude from either side. So the limit as x approaches -6 from the left, from which branch?
The second one.
Perfect. And when x approaches -6 from the right,
2 first.
what is the answer here? Perfect. What is the answer here? 2. So what is the answer here?
Doesn't exist.
Thank you. Anything else from this section on limits and limit laws before we move on to 2.4?
I'm sorry, I still don't understand where you got -2. I've been lost.
Sorry, say it again.
I don't understand where -2 came from.
This piece? Or this piece?
Where we originally got,
Yeah, this one? Or this one?
yeah, up there, when we wrote down -2, I was not sure where that came from.
Okay. This has two options.
Mm-hmm.
The first option is x plus 6. X plus 6 with L plus 6 will go away, and you have the answer 2.
Okay.
And the second option is the opposite of x plus 6. X plus 6 with x plus 6 will still go away, but there is a 2 and a negative 1 in the denominator.
Oh, okay.
Better?
Yeah.
Perfect. Other questions? Anyone? Don't be shy. Anything else? Okay, do you think we need other examples of any kind before we move on to 2.4? Yes, please, Sabrina.
Quick question. I don't understand how you got the -2 and the 2, was that, the one in the parentheses, was that from solving it?
So the
Or
limit
just
as
from
x
one?
approaches -6 from the left. -6 from the left, the function is simplified to -2.
So you just took what was in the,
But that's what it says.
okay,
That's why we simplified it without absolute value. We cannot use this.
Okay.
That's why we have these two options. We simplified it, and that's what we have to use moving forward. That's why we did all this, to simplify the function. Is that better? Perfect. Other questions, anyone? Anything else? Okay, so then we are going to move to 2.4. Any questions on that supplement that I asked you to work on several problems? Any questions on that? Is that done?
Completed.
No, just those that I selected.
go over number 12.
Yes, number 12. Can I borrow it again? Thank you. And number 12. It's exactly identical with what we just did right now. So we have a function, 4 minus x squared for x less than or equal to 2, and x minus 1 for x greater than 2. And we are asked to find the limit as x approaches 2 from either side of f of x. Thank you. So like before, we have to determine the limit from the left. So the limit as x approaches 2 from the left, from which branch? And the limit as x approaches positive 2 from the other side, and you'll tell me which branch.
From
2 from the left, from
left, I got 0.
from which function?
From 4.
Very good,
4
minus x squared. And yes, I got 0 too. Okay, from the other side, obviously, will be x minus 1, and we get 1. So what we conclude about the limit from either side?
Does not exist.
Does not exist. Other questions?
I got that answer. I didn't actually write the limit from the left and limit.
It's a must. Very good question. Whenever you are asked to determine the limit from either side, if there is any ambiguity, you must determine both sides. You cannot draw a conclusion, even if it's obvious, you still have to put it in writing. You have to show that every time you're asked to find the limit from either side, you have to find the limit from the left and you have to find the limit from the right. If they're equal or not, doesn't matter, you still have to show them and then you make a conclusion, draw your conclusion based on what you have for the limit from the other side. Very good question, thank you. I think I forgot to mention that. I showed it, but I didn't specify it enough. Very good. Other questions here before we move on? Other questions on those limits? Everything okay on those other limits? So can I just look at one more time? Did I select the squeeze theorem or not?
No, so the number 9, I think.
Okay. Okay, so yes, we did something similar to number 9. So now you have an example for number 9,
Okay.
right? So please do number 9. So number 9. You can do number 11 now. When we get the chance, I would like to show you this limit.
Which limit?
In number 13, I will show one example like that. And I will also come back to sine x over x, and then we'll look at this. So number 5, we're going to look at together. We're going to look at 4, top 1 together. So number 5 together, number 4, the first one together. I want to show the greatest integer function myself. This you can do. Please do number 9 and please do number 11. You have no difficulties with number 10 right now. Go ahead and do number 10. And I will show number 13. And we will have time for the rest. And these are, if you remember last time you asked me about one of them, you asked me about this one, if you remember, and we came up with the answer. So these are important limits. Okay. So I'll write it down at the end. So I'd like to discuss 2.4, and then I'll come back to those limits so we can make some more progress with that summary of limits. And I think I'm on page 3. Okay, so 2.4 is basically the only section in which you will see a formal proof in this class. So it's called the Epsilon-Delta definition, Epsilon-Delta definition. Or you will find it as Epsilon-Delta definition, or the precise definition of the limit. We like to say epsilon delta so we know what we talk about instead of the precise definition of the limit, but they mean the same thing. It will take me a while to explain because there are a lot of details in this proof. But once you see your first example, so you'll see how easy this is. So do not get scared, okay? Just pay attention and ask any question you may have. Let's look at 2 examples. It is a little bit abstract, but not difficult in the long run. So here's my first example with a function f of x. I'm going to put some numbers here for simplicity. I'm going to say 5. I'm going to say 7. So obviously x equals 5. And I'm going to ask you what is the limit as x approaches 5 from either side from this function f of x.
7.
Absolutely. I'm going to look at a different example. With a different function, let's say g of x. And I'm going to ask you what is the limit as x approaches 5 from either side of g of x. Not from the left, not from the right, but from either side. Yes. Now Colby will say, well, show me both sides, because that's what you said. True. But I have a different target right now. But yes, I would have said the limit from the left is, or were, 2 and 7. I would have written the limit from the left is 2, the limit from the right is 7, therefore from either side does not exist. Okay. Here is what it's called the epsilon-delta definition of the limit. We agreed that the limit exists here, right? Just assume that we are zooming in. If I just see this piece, do you think that the limit exists? I know it's a silly question. The answer is yes. What if I zoom in even closer to this point? Will anything happen? Will anything change? No, the limit still exists. Okay, this is basically the idea. Here's how. If I choose an interval, a symmetric interval around 7, this distance is epsilon. Of course, this distance is also epsilon because the interval is symmetric. So if this y value is 7, can anyone tell us the y value up here and the y value down here? What will this be?
Positive epsilon.
7 plus epsilon. What could this point be?
7 minus epsilon.
Of course. Perfect. Now, I determine the corresponding x value for this point. I go with the horizontal line, it meets the graph, and then come down to x. I repeat for the other one. I want to determine the corresponding x value for the bottom part of the interval. What interval? Between 7 minus epsilon and 7 plus epsilon. The bottom point has this x coordinate. The top value of y has this x coordinate. Okay. According to my graph, which of these two, I know it's silly, but I need this answer from you. Which of these two pieces is smaller?
The second one.
The second one, okay. So I will say, I will measure the second one on the other side, let's say about here. And this is 5. We are going to name this point 5 plus delta. And obviously, since I chose equal distance from 5, what will I call this x value then? 5 minus delta. And now we are ready to understand the mechanism. Ready? I hope you agree that no matter how small or how large epsilon is, I will always find the corresponding delta next to 5, close to 5. Would you agree? So if I have this epsilon, I found this delta. If I have this epsilon, I will find a different delta. If I have this epsilon, I will find a different delta. If I have this epsilon, I will find a different delta. But every time I pick an epsilon, I will find the corresponding delta next to 5. Why is that? Why does that happen? Because the limit exists. Let's go here. I claim that the limit exists here. Okay, so I'm going to choose this interval, this epsilon, and I'm going to show you that I found the delta. So this is my delta. I'm going to find a symmetric left and right. So I found 5 minus delta and 5 plus delta. I claim that the limit exists. I was able to find a delta. But the trick is, for every epsilon, not for one particular one that I can use it to be as large as possible to show that I can find a delta. You can say now, choose this delta. Or choose this epsilon. I'm in trouble. Because if I choose that epsilon, around any number you want, it doesn't matter. Look what happens, of course. Look what happens. I find with your epsilon that you want me to work with, I cannot find the interval next to 5. I cannot find the corresponding delta. So of course limit here does not exist because I cannot show that mechanism for every epsilon. I can show it for 10 million, but not for infinite. Okay, how do we put that in writing? This is the idea. We're going to use, it's up to you if you want to, we're going to use some mathematical symbols. You do not have to learn them. You can just simply use just plain English. Here is one mathematical symbol. It stands that for every or any. For every or any. This symbol stands for exists. This one, such that. I'm gonna write the definition in plain English, and then if you'd like, at least I will use those symbols for simplicity. You don't have to. You can just change them into plain English. But first, the definition in plain English. And then I'll show you how we prove this for different functions and for different limits. Okay. For every epsilon, it has to be positive. It cannot be 0. It cannot be negative. For every epsilon greater than 0, there exists a corresponding what? Greater than 0, such that, okay, so let's stop for a moment. Let's come back here. Would you agree that now, since for this epsilon I determine this delta, if I pick x here, or anywhere between this point and this point, anywhere, not outside, but anywhere between 5 minus delta and 5 plus delta, if I pick not 5, because remember x is not 5. So I can pick x here, or here, or here, or here, or anywhere you want in this interval. Where do you think f of x, the corresponding f of x for this point, for this x value will fall? Mandatory within epsilon away from 7. Okay? Why? Because the limit exists. Such that, so let's recap. For every epsilon positive, I will find there exists a corresponding delta positive such that for every, or any time, better, anytime I pick x close to 5 in our case, but it's normally a, denoted by a. Our 5, the numerical example I picked was x equals a, but a equals 5. So when we say I pick x close to a, I really mean distance between x and a is less than, mandatory, less than okay, the distance between x and a is this, must be smaller than, of course, mandatory, smaller than delta, less than delta. And this in mathematical terms, we write it as x minus a less than delta. And x does not equal a, so we're going to put on the left-hand side this, greater than 0. And you could say that's redundant. We know that x minus a in absolute value, which is the distance between x and a, we know it's the distance is positive, true. But this signifies that the distance cannot be 0. In other words, you cannot pick a to be x or x to be a. One more time, we didn't finish, one more time. For every epsilon greater than 0, there exists a corresponding delta such that, greater than 0, such that anytime I pick x close to a, which means the distance between x and a is less than delta, but greater than 0, not equal to 0. Okay? Every time, anytime I pick that, it's corresponding f of x, corresponding to x, right? It's corresponding f of x will fall where? Close to we use 7, but in general we use L, close to the limit L. How close? the distance between f of x and L must be less than. Excellent. I know it could be a little confusing at first. A lot of words, half a page, but of course, half a page for me. It's not going to be half a page for you. So here's how we write this in one line with mathematical notation. The limit as x approaches a from f of x is L. In other words, what we had, the limit of f of x as x approaches 5 is 7. That was our numerical example. Is equivalent to, this is the double equivalency symbol, which means this implies this, what I'm going to write. This implies this, double equivalency. This implies this, what I'm going to write in a second, and this implies that. Ready? For every epsilon greater than 0, there exists a delta greater than 0, such that every time I pick x close to a less than delta, this will always imply that the absolute value, the distance between f of x and the limit, will be less than epsilon. It looks and sounds gibberish, probably. It will be very simple in a moment when we look at examples. So all that half a page means, one more time, for every epsilon, because the limit exists, I can choose any epsilon as small as you wanted it to be, 0.0001 if you want. We will determine a corresponding delta that depends on the epsilon we picked, such that every time we pick x close to a, so that the distance between x and a is less than delta, the distance between f of x, f of this x that we picked, minus the distance between that f of x and the limit will always be less than epsilon. And this will only happen when the limit exists. Okay, a lot of talking. Let's look at an example and see how this works. On page 117, I'm not going to ask you anything about the infinite limits. I'm not going to ask you about anything but linear functions. Just the simplest possible example, okay? You don't have to worry about quadratic functions or cubic functions or any other function, just linear. So here's problem. Let's make one up before we look at those examples. 16 is good. I want to start with a simple example, that's why. So limit as x approaches, I think it's negative, no, it's positive 4, okay? From 2x minus 5. What do you think this is? It equals 2? Yes? How much?
3.
Very good. This is equivalent to, I need the definition so I can refer back to it. For every epsilon greater than 0, there exists a delta greater than 0 such that every time we pick, so for every epsilon greater than 0, there is a delta greater than 0 such that every time we pick x close to which number in our case? Yes, excellent. Excellent. X minus 4 less than delta. This will automatically imply what? The function minus the limit, absolute value, the distance between the function value for this x that we pick minus the limit is less than epsilon. What is the function? Minus the limit?
4. Oh, shoot.
That's okay, that's okay. Less than?
Do we have it?
So x goes with delta, right, on the x-axis, and the function goes with,
So would it be negative 5?
I took this away too fast. Sorry. The function minus the limit less than epsilon, right? Because for every epsilon, I find the corresponding delta such that when I pick x here, the corresponding f of x will fall at the distance from 7, or in this case L, right, smaller than epsilon. Okay, so this is what we are trying to prove. We always start with the end. So step 1. Tell me how to write the end, so I don't write it again like this. Is there anything I could do to it? The absolute value of 2x minus 8 less than epsilon. This is not cheating, but I want to see what I have to get. This is what I'm after. Whatever I do here, whatever algebraic manipulations I'm allowed to perform, this is my target. To get on the left-hand side the absolute value of x minus 4 and whatever in terms of epsilon on the other side. So look at this inequality and say, and I want to refresh your memory on two properties of absolute value before we continue. The absolute value of A times B is the absolute value of A times the absolute value of B. That's one property of the absolute value. The absolute value of a product is the product of the absolute values. The same thing values for the ratio. The absolute value of A over the absolute value of B. These are properties that we have to mention in the proof whenever they come into play. Okay, so now, what do you think we're going to do? Look here and say, yes, I know you're going to. Excellent. What is left in parentheses? Excellent. We're quite close. Now, this is a product. I have to use this property. And I have to write it, although we know that the absolute value of 2 is 2, but I have to write that step. Which step? Can anyone dictate the next step? Now I can apply, I can determine or simplify the absolute value of 2, which is 2. I write x minus 4 in absolute value less than epsilon. And now I have x minus 4 less than
Epsilon.
compare these two. And give me delta, please. That's it. Okay, so now I want to discuss a numerical example based on this. If I tell you epsilon is 0.1, give me delta, please. You don't have to calculate, just say 0.1 over 2. If I say epsilon is 0.4, can you find the corresponding delta for 0.4?
0.4 over 2.
If I say epsilon is 0.001, can you find the corresponding delta for epsilon being 0.001? Why does this work? Because the limit is indeed exists, and is indeed, in this case, 3. There is also a second step. I will not ask you to perform it, but you have to write. Because of the double equivalency, we have to show both sides. All I want you to write is show that delta equals epsilon over 2 works by reversing the steps from above. That's all I want you to write. Just this sentence and not do anything else. By reversing the steps from above. I just want to make sure that you understand that both sides have to be shown. But you don't need to go through the steps for the second one. Works by reversing the steps from above. That's it. Something that looked kind of difficult at first, It's really not, especially for linear functions. Now, if we go into quadratic functions, it's a different story. So before we look at the numerical example, I would like you to work on any problem. So let's work on 18, or maybe two problems. So limit as x approaches -2 from 3x plus 5 equals -1. Write the definition the way you like, but you have to write it. Either in plain English or with those three symbols, it's up to you, but you have to write something. You have to write the double equivalency, and then put the definition. And then step 1 and then step 2. I'll come around to help you, anything you need. Because I don't want you to spend 10 hours on this definition at home. I want us to work on at least one problem every 2, and then we move on to continuity. Oh, did we show that again? There was nothing else I needed to show, right? It was the problem that we looked at was the one that we just did, right? You showed me a problem last time, but it was the one that, okay, I just don't wanna forget. Yes, I remember, it was that one. So we write the definition first, either in plain English or with the symbols. How does it look like? For every epsilon positive, it's a must, right? For every epsilon greater than 0, there exists, yes, a delta greater than 0, excellent. There is existence rate at a delta greater than 0, such that, again, you can replace those with plain English. If you don't like those symbols, that's fine too. Such that, very careful, remember delta and x go with a. So x, a, and delta have to be in the same inequality. The function, the limit, and epsilon in the other inequality. So careful here, careful. Okay? So these two go with delta. These two go with epsilon. Yes, excellent, yes. That implies the function minus 1. Excellent. So we start from here. Excellent. So let's put number 1 and write 3x plus 6 less than delta. In absolute value 3x plus 6. Are we okay?
3x plus 5.
So 3x plus 6 because it's minus 1.
Oh, that's right.
Right? So it's the distance is not between f of x and L is not f of x plus L. The distance in absolute value is f of x minus L.
Okay.
And since L this time is -1, then that's why how we have, and you know exactly that something would be wrong because you would not be able to get the x plus 2 if you, by mistake, you put -4, right? Or +4, because you will not be able to factor out the 3. How are we doing here? Yeah, you prefer the book for that? Okay. So, yes, excellent. So now, once you compare these two, oh, you didn't write this correctly.
I like that.
So this is x plus 2 instead of that. So this is x plus 2. So x and 2 and delta go together, and the function and the limit. So now you have to write equals delta, and you found it. And in step 2, you have to say that you have to write that. You'll not be able to use this on the test though. Sorry. Not too difficult, is it? As long as you remember that x goes with a and delta, and then f of x with epsilon and L, and you keep those separate, it's not going to be any problem. And we can look at another. Yes. Yes, everything is good. Just start with the end. We got it?
I don't know what to do for step 2, like, what do you mean by that?
Oh, that's all you have to do. You just have to write. Step 2, show that delta equals epsilon over 3 works by reversing the steps and getting back to the starting point. But you don't have to perform. Exactly, in this order, but I'm not asking you to reverse them. But you have to write it. So then I know that you understand that the double equivalency proof has to be shown from left to right and from right to left. Okay? So let's look at one more and then put this to rest. So for every epsilon greater than 0, there exists a delta greater than 0 such that 0 less, you understand that 0 less is not redundant. It simply says you cannot pick x to be -2. That's all it means, right? The absolute value of x minus a less than delta will imply that the distance between the function and the limit minus -1 must be less than epsilon. Every time I pick x close to -2, the f of that x will be close to -1. Okay, so I start with the end. So this is 3x plus 6 in absolute value less than epsilon. Exactly what we did before. We factor the 3. I know exactly what I'm after. And I'm getting it. But I have to write this step. Regardless of if it looks redundant or not, please write this. And then 3x plus 2 less than epsilon. And then x plus 2 is less than epsilon over 3. When you compare, the left-hand side is this, less than, this must be the corresponding delta based on the epsilon. So this must be delta, and then I will say just reverse. And you know what I mean, and we have to write this second step. So if you say, I want the epsilon to be 0.1, I'll say fine, then delta will be 0.1 over 3. You want epsilon to be 1. Huge, but that's okay. So then delta is 1/3. Is that clear? Feeling better about this? Okay, so let's do one more, like 20. And then I will still would like to look at a numerical example because you may encounter those in WebAssign. So this is limit as x approaches 10 from 3 minus 4/5 x, and please give me the answer.
It's -5.
Excellent. So please let's work on this.